All right, prepare yourselves for a lot of talking and not a whole lot of writing. We got to get through some of the terminology associated with the hyperbola, and it is robust, to say the least. So I'm going to do a lot of comparing the hyperbola to the ellipse. I've already mentioned that the equations are the same, except the hyperbola has a subtraction in the middle, where the ellipse had the addition in the middle. I also want to remind you on the ellipse that the sum of the distances from any point to the foci on the ellipse was always the same. Okay, now let's talk about the hyperbola. The hyperbola is a set of all points P in a plane, the difference of whose distances from two fixed points, called the foci, is a constant. So a hyperbola also has foci. But here's the difference, and I'm here on this graph on the left at first. If I pick any point on either of the curves and I draw a line from that point to one focus and to the other point, or to the other focus, and I subtract those distances, then I pick a different point anywhere on the same hyperbola curve or on a different one, and I measure that distance to one focus and that distance to the other, and I subtract, that difference is a constant. It will be the same every single time. So you can think hyperbola has subtraction in the middle, the difference is the constant. Ellipse has addition in the middle, the sum is a constant. All right, turning our attention over here to the graph on the right, you see a general hyperbola. This one opens to the left and to the right. The concepts apply even for those opening up and down. So I want you to keep that in mind as we discuss the parts. A center exists. It may be at the origin or it may not be. And then you have vertices. If the hyperbola opens left and right, the vertices will be to the left and right of the center. If it opened up and down, the vertices would be above and below. Then you have foci, one focus and another focus. These will be inside the curve. The foci are always on the inside of these curves. So the focus will be on the inside of the curves, and they will be a distance C away from the center. We'll talk about how to calculate C in just a moment. So we've talked about the center, we've talked about the vertices, we've talked about the foci. Let's talk about the asymptotes. The asymptotes will always pass through the center. One will have a positive slope, one will have a negative slope. And we've mentioned in a previous video how to find those values, and we'll see that here in a minute again as well. A couple of new pieces of terminology associated with the hyperbola. The transverse axis. Now notice that the transverse axis, in this case it's horizontal. If ours was opening up and down, it would be vertical. The transverse axis passes through the focus, the vertex, the center, the vertex, the focus. So transverse, it is transversing all of these points, transverse. Then perpendicular to the transverse axis, we have what's called the conjugate axis. Please notice that both of these axes pass through the center. They are perpendicular to one another. The transverse passes through all these different points. The conjugate only passes through the center. All right. You'll see the symbolization, I guess you could say, of the statement about the constant distances down here. Again, the transverse axis contains the foci. It also contains the vertices, just to say. The center is the midpoint of the segment that contains the foci. In other words, the foci are the same distance away on each side of the center. And then the conjugate axis is a line through the center perpendicular to the transverse axis. All right, so those are all the moving parts, or not so moving. What about the standard form? Well, they are very similar. One has x being the positive term, one has y being the positive term. So we will consider both of these. When x is the positive term, it means the hyperbola opens left and right, center at HK. The vertices are A units to the left and the right of the center. The foci are C units to the left and the right of the center. This time, C is found by a squared plus b squared. Now, how refreshing. That seems just like the Pythagorean theorem. And if you will take the time to read in your book about the development of the equation of the hyperbola, you'll see why that's the case. So, with the ellipse, which had a plus in the middle, we subtracted a squared minus b squared to get c squared. With the hyperbola, which is minus in the middle, we add a squared and b squared to get c squared. Slopes of the asymptotes are positive or negative b over a, as we have discussed. And if you ever had to write the equation of the asymptotes, I would suggest using point slope form. That's what you see here, with the point being the center, because the asymptotes always pass through the center. So y minus the y part of the center equals the slope of the asymptotes times x minus the x part of the center. This information is very, very similar when it comes to the hyperbola opening up and down, indicated because y is the positive term. And this time, now notice, again, the whole A and B thing in your book, it's not just your book, it's all books. I would almost just throw A and B out the window. Just remember the 1 under y is the numerator, the square root of that is the numerator of your asymptote slope. The square root of the 1 under x is down here on the bottom. And it won't matter the order you add them in because adding is commutative. All right, so we will now turn our attention to using so many of these terms as we actually sketch a graph of a hyperbola, labeling the important information.